Review topic 19, periodic table trends. Let's get started. Okay, so we have a bunch of trends to know. We have ionization energy. Ionization energy is literally how much energy it takes to pluck away an electron. Atomic radius, the relative size of an atom. We have to measure it kind of based on bond radius, but just know atomic radius is the relative size. Electronegativity is the ability to attract an electron in a bond. Electron affinity is the energy change that happens when a neutral atom gains an electron. So electronegativity and electron affinity, see how they kind of sound the same anyway to me? They will follow the same trend, okay? And then we have metallic character and non-metallic character, and we will talk about those. All right, so the one exception, the kind of one weird one I want to talk about is boiling point and melting point. So you can see based on the shading. So as you go across a period, the boiling point and melting point will increase, then decrease, and then kind of make another little bump up again and back down. So it doesn't follow the same trend as other ones do, like ionization energy, where as you go across, it flat either increases or decreases. But it does follow a trend, meaning predictable. It's going to go up and down and then up and down again, but in a smaller amount. So up and down and then up and down. All right. So that's boiling point and melting point. You can still find these values on table S, so it's not a memorization thing. So let's look at what all these trends are. Remember, ionization energy is the energy to pluck away an electron. And it is the biggest right here in this corner. So in this corner, it would be the lowest. All right. Electronegativity, the ability to attract an electron, okay, is the highest right here. F, fluorine, has a 4.0. Perfect GPA. Perfect electronegativity. But it's just kind of funny to me because it's an F, the worst grade. So electronegativity is highest right here and then lowest over here. And then when we talk about atomic radius, right here, it will be the largest. Up here, the smallest. Electron affinity, remember, follows the same pattern as electronegativity. Electronegativity was the ability to attract an electron. Electron affinity is the energy change that happens when an atom does in fact gain an electron, okay? And then we have metallic character. So down here, most metallic kind of element, least metallic. And then in terms of non-metallic, we have most non-metallic up here and least non-metallic down here. Now, if you forget, and you're like, oh my gosh, I forgot what Mrs. Jenkins told me for this trend, you can look up ionization energy, you can look up electronegativity, and you can look up atomic radius. Now, you can't look up electron affinity. This is not there, but remember that it sounds the same, sounds similar to electronegativity. And you can't look up metallic character. But if you remember that metals want to lose electrons, that means they don't want to attract them. So it's going to be the opposite of electronegativity. At least that's how I think about it. And there you have it. Periodic trends in a abbreviated version.